In this video, we are going to make a fire machine with the help of a few batteries and water. In fact, my plan is to create a structure using these batteries that separates water into two atoms of hydrogen and oxygen. As you know, oxygen is part of the hard triangle of hydrogen, and we will use this element in the experiment. Let's get to work.
As you see in this picture, we have two frames and there are main battery. And we connect the wires alternately to two different points. And this is our bottle. We fill it with water and KOH, or you can use salt. First, we remove the battery casing and take out the battery core. Now we use this plastic blade as the base and place the battery core on top. Okay, we need to make system such this. Let me explain what we done so far. After assemble this, we wrapped a wire around each end of battery cell. I initially tried to solder the wire, but unfortunately it didn't work. So I wrapped a wire around the battery core instead. The most important thing here is to perform continuity test with a multimeter. We set a multimeter on continuity test and then check the circuit. If the circuit is connected correctly, the multimeter will beep only when the connections are made alternately. Otherwise, it won't beep. Now we take a bottle, unscrew the cap, and we want to attach this part on this cap. We'll drill two holes, one for a hose and one for a wire. Make sure to seal these holes completely with glue. Okay, we fill bottle with water. Then we added 3 tablespoons of potassium hydroxide. Okay, let's test it and connect it to power supply. Unfortunately, it didn't work. Let me see why.
Well, as we saw, we conducted the experiment on this bottle, and it seems that it wasn't done correctly. What I checked could be because the mouth of the bottle was a bit loose, allowing too much air to escape. The hydrogen, as mentioned, could become loose and catch fire from there. That's why we want to implement the entire system on this bottle to reduce the air escaping from it.
As you can see, we completely redesigned the extractor because the previous one exploded during testing. We used 2 popsicle sticks and replaced the battery core with screws, and we soldered the wire directly to the screws. We need a chassis, so we make with popsicle stick in this video. We also need the armature and 4 wheels. Okay, we are going to connect the battery in series. Each case is 3 volts. Okay, when we connect them we have 9 volts. We need to connect the positive terminal of one battery to the negative terminal of the next. Or we can use 9 volt battery instead. Okay, we attach bottle in here and ignition module here and attach power switch here. Okay, so this is a diagram I draw so you can understand how the circuit is connected. These are 3 batteries connected in series. This is main switch. When you turn this switch on, the entire circuit is powered. This is 3-prong table. One branch goes directly to the hydraulic device. When you turn on main switch, the hydraulic device starts to work. This switch is for a pair of armature. This is actually the push button switch that I hold. When I press it, the robot moves forward. And there is also a wire and push button for a shocker. A negative wire is also connected to the entire circuit. Okay, I explained the last changes I made in robots. Its movement was a big problematic due to the weight of the water. The other circuits remained the same. That's why we replaced the previous armature with these two. Since I couldn't find the wheel of that size, I used the bottle cap instead. I tried to test the move of the robot and test my shocker. And check my hydraulic device. And finally, it's worked. Thanks to watch.